tapos saka natin i-discuss once you have your solution na. Okay? So, example 2 naman po, nasundan po ba yung sinabi ko? Hello? Interrupt mo
Opo.
na po. Okay, dinin mo na po tayo ha ulit. So, I'll guide you lang po on how you will be solving this one. Okay? So, here, yung problem 2 po natin is under pure bending. Okay? So, a shaft with K equal to 0.9 made of C1045 as rolled transmits 60 kilowatt power at 1350 RPM. Okay? Shaft is loaded with 12-inch spar gear located mid-span of the total length of 36 inches. Okay? And consider static load and bending effect only. Okay? So may nakalagay po doon, bending effect only, compute for the required diameter. Okay? So pag wala po kasi nilagay dyan na consider bending effect only, and the fact that you are given here the value of yung power, okay, this would be a combination of torsion and bending. Okay, so yan po, yung power na yun, that's the indicator for yung torsion. At yun naman pong gear that has been loaded to it, that's an indicator naman po para doon sa bending. Okay, so with that po, you would say that this is under combined torsion and bending. But because of this statement that you consider static load and bending effect only, so ibig sabihin, yung torsional effect po natin, okay, ay hindi po natin isasama. Okay? So, yan po yung ibig sabihin nung problem na ito. Pero kung wala po yung statement na ito, okay, na bending effect only, this would be a combination of the two. Okay? Now, so with this po, okay, so this would be under pure bending. Okay? So with the value ng pure bending, okay, so you start with the given values. You have the diameter ratio equal to 0.9. Okay? Power, this is equal to 60 kilowatts. And yung N natin is 1350 RPM. That would be yung speed. Okay? And then you have here the diameter, okay? 12-inch spar gear located mid-span. Okay? So if this is your point A, okay, we label this your point B, yung point C. Yung nandun po sa point B would be your spar gear. Okay? So this is yung spar gear with a diameter equal to, okay, 12 inches. Yan. So it's mid-span. So the total length is 36 inches. So kung nasa kahalahati, it would be at 18 inches. Okay? So we have here your spar gear, then that contributes to the bending load of your member. Okay? So yun po yung nagbibigay ng bending load. Okay? So the diameter here of the spar gear at B, okay, is equal to 12 inches. Okay? Yan. Total length is equal to 36 inches. So these are the given values. Okay? Now, we have here the material specs. So we have AISI C1045 as rolled. So kuhanin lang po yung kanya na property. Okay? Then you would have there the factor of safety. So since wala pong factor of safety na given, then you can refer to your yung table po natin, table 1.1. Okay? So page 1 doon sa atin na design tables. Okay? And then, after the factor of safety, you have the design stress, okay? So, you compute for the design stress. It can be in terms of sigma U or sigma Y divided by the factor of safety, okay? So, looking at the problem, you are not given, okay po, yung basis of design. So, ano po yung ating magiging basihan? It would be po yung type ng material. So, since this is not yield, the design stress would be based on the yield. Okay? And then, how would you solve for this one po? Okay? So, okay, kayo na po magsundo na rin ha. Factor of safety. Next, we have there design stress. Again, your design stress would be sigma D equal to sigma Y divided by factor of safety since this is ductile. Tanong lang po is bakit po ma'am sigma ang ating ginamit? Bakit po hindi tau? Okay? Why? It is because ang kinoconsider lang natin is the bending effect. Okay? And what you will do is to equate, okay, the sign stress to the induced stress of the material. So your sigma D would be equal to your flexural. Okay? So what would be the equation for the flexural stress for this hollow shaft? So it would be 32m over pi d cubed times the hollow factor 1 over 1 minus k to the fourth equal to your sigma D. Okay? So ito po yung magiging equation natin. Okay? Now, yung K po is given, we are looking for the diameter. Kailangan muna po natin malaman yung value ng M. Okay? So, saan po natin makukuha yung value ng M? Okay? So, for M, okay, alam po natin M is the maximum moment. Okay? So, ano po muna gagawin natin? You create a shear and moment diagram or you may use po yung equation natin on dyan sa table kung may kaparehas. Okay, and I think this is meron po katulad dyan. Ano nga pong figure yung ating gagamitin? Okay, so that's or table. Tandaan po ba? Hello? Hello?
Table 82 po.
Okay, so that would be table 8.2. Okay, so 8.1 would be for the cross-section, table 8.2 para doon sa maximum moment. So you can get po, kung may katulad nito, you have your corresponding reaction at A or force at A and reaction at point C. Okay, so kung may katulad po nito, doon sa atin na table 82, then you can make use of that table, kuhanin po yung equation ng M maximum. Okay? To obtain po yung M. Okay? Considering this FB. So, need mo muna po hanapin yung value ng FB. Okay? So, how do you obtain the value of FB? Katulad po ng sinabi ko kanina, it will come from the power. Okay? So, from power po, okay, you can convert po the 60 kilowatt into HP. Okay, so convert it po into horsepower, yung 60 kilowatts. Okay, so know the conversion between the two. And from there, kunin mo po yung equation ng power. Okay, so power is equal to TN over 63025. Okay, so from there, you solve for torque. Okay, 63025 times the horsepower equivalent divided by yun po N. And what is the value of N? 1350 RPM. Okay, and your answer here would be in pound inch. Okay, but then yung torque na yun is different pa po with this FB. So to obtain this value of FB, it would be equal to torque divided by yung radius ng gear B. Okay? So, torque divided by radius ng gear B. So, kung ano po yung sagot natin dito, yun po yung substitute natin doon sa taas, divided by radius, this is 12, so it would be 6 inches. So, you'll have your answer now, FB in pounds. Nakuha? Naintindihan po? Hello? And once you have this FB, okay, so once you have this FB, you can now solve for M. Okay? Alin po ang gagamitin natin? Using yung table 82. Okay, meron po doon equation M max is equal to FL over 4. Okay, FL over 4. Pagka po ganito nasa gitna. Okay? And from there, you'll obtain yung value ng M. Nasa-substitute po natin dito to obtain the diameter. Okay? Nasundan po ba yung gagawin? Hello? Okay, so ituloy po yung solution nyo up to this problem 2. Okay? So, i-copy mo na po ito and then I'll have mamaya po yung presentation doon na po sa atin na Jamboard. Okay? So, take a screenshot of this first po para mailipat ko na po yung screen doon sa Jamboard for your solution. So, tatandaan niyo po ha, ano po yung minention ko kanina. This is under bending effect only. Kung wala po yung statement na yan, ano po yan? This would be a combination of the two. Okay? So, mamaya po, we will be solving this pa rin, okay? Kung combine na po sila. Tell me po pag okay na, nakopy nyo na itong direction dito sa problem for your guide po on solving.
Okay na po.
Okay na? Hello?
Okay na po.
Okay, thank you, Justin.
So both floating and sinking situation is explained by Archimedes' principle. And according to Archimedes, this machine, he found out that the buoyant force and its direction controlling a free body diet upward, going up. So buoyant force when rowed in the FAB or big wind, and thus is upward. At ito daw ay equal saan? Sa wave. So again, force ito, so ang unit ito ay Newton pounds pa rin.
Please include po yung name nyo ha. Okay? Okay, and then paki-continue dun sa problem 2 before we discuss your solution. Okay? Thank you.
BF in ating buoyant force equals, bakit naging rho G times rho U? I-write natin ang palayan ng manual okay? Plus ang derivation. Lapit naman manual yung sunod na yan. So, derivation. Okay, derivation. Yes. The derivation
Asa na po yung sa iba na solution? Okay? I am tallying up din po dun sa mga nauna natin na mga jump board. Okay? And it seems that yung iba, yung mga lagi lang din sumasagot sa akin dito during our online class, siya lang din yung mga nagsasagot. Okay? Meron talaga na hindi nagsasagot kahit kailan. Okay? When I tally po yung mga jump board po natin.
The weight of the solid na nasusukat ng spring balance.
So I encourage po everybody to please po, okay, although this is online, this is our only way for you to participate, okay? By simply pasting po yung inyo na solution dito sa atin na jump board. Okay, so I want to have first yung solution natin on problem 1, rents. Hello.
Hello po.
Okay, I want you to explain your work, rents, on problem 1. Okay?
For problem 1 po, kinuha po muna yung sigma U and sigma Y sa table 80. Sorry pa, hindi ko pa nalagay. Table 88 po. And then, nakuha ko po ay 100 KSI for ultimate and 85 KSI naman po for yield. Pero dahil po nasa pure torsion po tayo, kailangan po natin ng tau, hindi po yung sigma. So may question po tayo na to get the tau ultimate, multiply po natin ng 0.75 and then yung tau yield naman po is multiply po ng 0.6. Tapos po, yung 85 KSI po, which is yung ating sigma y, minultiply lang po ng 0.6. Kaya po nag-arrive tayo sa answer na 51 KSI. And then, inassume ko po na yun ang gagamitin nating yield since using the relation DYBU, yung 45 po is pumapatak siya sa ductile. And then, kinuha po ang factor of safety sa table 1.1 po. And then, based on yield po, and nakuha po ay 2. Tapos po, unang-una po, kailangan po natin ng torque para magamit dun sa ating equation. Pero, wala pa tayong torque. So, kukunin po natin siya gamit yung equation for power na P equals Tn over 63025, where P must be on HP and must be on RPM. Tapos, ang makukuha pong sagot dito is naka-pound inch. So, nag-arrive po tayo sa sagot na 31,512.5 pound inch. And then, direct sub lang po, 16, equate pa natin yung induce sa design stress. So, for induce stress, since siya ay hollow, so yung atin pong equation na for solid, multiply po natin yung hollow factor na 1 over 1 minus k raised to 4. Given naman po yung ating k na 0.7. So, 16 times yung tipo natin na 31,512.5 pound inch. Kailangan po natin convert siya ng kip inch since yung atin pong taway ay naka-KSI. So, multiply lang po natin 1 kip over 1,000 pound. So, over pi d cube. Then, yun ay for solid pa lang po. Multiply po natin yung for hollow, yung hollow factor, 1 over 1 minus 0.7 raised to 4. Tapos, equate po natin siya dun sa ating design, which is 51 over 2, 51 KSI over 2. Ito po yung ating taway over Fs. And then, shift solve, ang nakuha ko po ay 2.023261952. And then, by looking po sa ating preferred sizes, ang pinakamalapit po sa kanya na mas mataas ay 2.125 inch. And then, yun pong standard size na ginamit ko, yun na lang po yung minultiply ko ng 0.7 since ang K nga po natin ay the ratio of the inner diameter sa ating outer diameter. So, K equals D over D na malaki. And then, manipulating the formula, yung D na maliit is equal yan sa D na malaki times K. So, i-multiply lang po natin ng 0.7 yung standard size kanina sa outer diameter, and then makukuha po natin yung inner diameter na 1.4875 inches. And then, i-convert po ulit natin sa ating standard size. Ang pinakamalapit po ay 1.5 inch.
Okay, thank you guys. Okay. So our answer here would be outside diameter is 2 and 1/8 of an inch, and then this one is 1 and 1/2. Okay. So alin lang, okay, ano lang idadagdag natin dito rin and the others also. Okay. Again, you follow po yung ating procedure on designing. Okay, start with the given, material specification, factor of safety, design stress, and then equating design stress to the induced stress. Okay? So, yun po yung ating idadagdag lang dito. Okay? Nakuha po ba, friends?
Yes, ma'am. Thank you po.
Okay? So, the others, ganun din po yung gagawin natin. Okay? So, as I browse naman po dito, okay? So, everybody na may solution dito has yung answer po na yun. Okay? The same answer po. So, anyone who has posted here po yung para dun sa 2? Okay? Okay, so yun naman po number 2, madali lang din po yun since you do not need to provide a shear and moment diagram. Okay, as in stated in table 82, okay, meron ka na po the equation for the maximum moment. Okay, so you simply have to ano lang po, mag-substitute po. Okay, so mostly po ay problem 1 pa lang. Okay, so kindly post na rin po your answers in problem 2 so that we can discuss. Okay? So, ilan na lang pong minuto para po ma-discuss natin. What would be the dimension if it is under pure bending? Sino po may answer na para po ma-discuss po natin? Please tell me po pag meron na po kayong na-post for problem. Okay? Okay, I think we have here answer of Agopo and meron pang isa kanina. Kanino nga ba yun? And Enriquez. Okay? Any of the two can present their work. Enriquez or Agopo?
We are